You know that feeling, right? You see a shooting star blaze across the sky, you make a wish, it feels like magic. But what if I told you the truth behind it is a wild story of incredible speed, cosmic ghosts, and something so common you've probably got it in your shoe right now? Yeah, for real. So let's get into it and uncover the real science behind a meteor shower.
So what is that flash really? Is it actually a star falling? Maybe a chunk of an asteroid? Well, the truth is, it's way, way smaller than you'd think. Go on, take a guess. I'm pretty sure this one's going to surprise you.
That's it. A single grain of sand. I'm not kidding. Almost every single meteor you've ever seen in your life was caused by a particle that tiny hitting our atmosphere. It sounds impossible, right? I mean, how on earth can something so small create such a brilliant, spectacular show? Well, that question, that's the whole secret we're going to unravel. Okay, before we get any deeper, let's get our terms straight real quick. It's super simple. If you see just one streak of light, that's a meteor. But if you see a whole bunch of them, dozens, maybe even hundreds over a few hours, that's a meteor shower. That's when Earth is plowing through a whole cloud of that cosmic dust. Simple difference, but it's a really important one. And that brings us right back to that big question. If it's just a tiny speck of dust, how does it make that flash? It's not burning up the way you'd think, like a log on a campfire. The secret has nothing to do with its size and everything to do with its absolutely unbelievable speed. Get ready for this. These little specks of dust slam into our atmosphere at speeds up to 160,000 miles per hour. To put that in perspective, that's over 200 times faster than the speed of sound. It's almost impossible to even wrap your head around how fast that is. And for everyone using the metric system, that's about 257,500 kilometers per hour. Now, when something is moving that fast, the air molecules literally can't get out of the way in time. Instead, the particle creates this insane shockwave, compressing the air in front of it and heating it up to thousands of degrees. And here it is, maybe the biggest mythbuster of all. We call them shooting stars, but nothing is actually burning. The little particle itself, it's usually vaporized almost instantly. That brilliant streak of light you're seeing, that's not the rock. That is the air itself, superheated until it glows like a neon sign. It's a tube of plasma. The scientific name for this whole process is ionization. Basically, that incredible speed physically rips electrons away from the air molecules. But then, those molecules want to get back to normal, right? And when they snatch an electron back, they release that extra energy as a photon, which is just a particle of light. And that's the flash you see. All from a tiny grain of dust moving so fast it forces the air itself to light up. And hey, while you're out there watching, you should keep an eye out for the real show-offs. You know, the overachievers. If a slightly bigger particle comes in, say the size of a pebble, it can create what we call a fireball. These things are so bright they can actually outshine the planet Venus. You can sometimes even see them during the day. And some of the coolest ones leave behind these eerie, twisting smoke trails that can just hang there in the sky for minutes. All right, so now we know what a meteor is. But that brings up the next question. Where do these giant clouds of sand and pebbles even come from? Well, for that we need to zoom out. I mean, way out. We're going to follow the ghostly trail of a comet. It's all part of this incredible, perfectly timed cosmic dance. So imagine a comet orbiting the sun. As it gets closer, the heat makes its ice vaporize, and it sheds this long trail of dust and rock, like cosmic breadcrumbs. That debris trail just keeps orbiting the sun, like an invisible river flowing through space. And then, once a year, our own planet, Earth, on its own orbit, flies right through that stream of debris. And the result? You guessed it, a meteor shower. And that is why they're so predictable. It's like clockwork. Every single August, Earth passes through the debris trail left by comet Swift-Tuttle, and boom, we get the Perseid meteor shower. Every December, we fly through the trail of this weird rock comet thing called 3200 Phaethon, and that gives us the Geminids. We're basically setting our calendars by these cosmic intersections. So here's the best part. This isn't just some abstract science lesson, right? This is a real-life cosmic spectacle that you can go out and watch for yourself. And you don't need any fancy equipment. So let's talk about how you can get the best seat in the house for the show. The tips for this are super simple. First, get away from city lights. The darker the sky, the more you're going to see. It's that easy. Second, be patient. That means putting your phone away, seriously, and just letting your eyes adjust to the darkness for at least 20 minutes. Third, timing is everything.
The show is usually best after midnight. That's because our side of the Earth has turned to face the direction we're traveling through space, so we're hitting that debris stream head-on. And maybe the most important tip of all, you don't need a telescope. In fact, you don't want one. Your own two eyes are the perfect tool for taking in the whole sky at once.
And you know, as you're out there, lying on a blanket and just looking up, take a second to think about this. You're taking part in one of the oldest human traditions there is. For thousands of years, people have looked up at these falling stars. They've recorded them in ancient texts and art, all the while wondering what they were. It's a spectacle that connects us not just to the cosmos, but to every single person who has ever looked up in awe. So there you have it. The next time you see a shooting star, you'll know exactly what you're looking at. It's not a star at all. It's a tiny grain of sand, maybe left behind by a comet centuries ago, ending its long journey by making the very air around it glow in one brilliant, silent flash. You're watching Earth's high-speed dance with the ghost of a comet. And it just makes you wonder, doesn't it? What other cosmic secrets are hiding up there, right in plain sight?